you find yourself repeatedly training your machine learning model because you've accumulated more data? And are you unsure what to do about the hyperparameters? Then the good news is that we've investigated. This is work done at AWS AI Labs with the wonderful Huibin, Francois-Xavier, and Aaron. In obeying the order introducing ordered transfer hyperparameter optimization, we assume access to evaluations from previous optimization tasks and that there is an inherent ordering between those tasks that we can exploit. The obvious question is whether such an ordering exists, and the answer is yes. In these plots, we show the optimal hyperparameter configuration as we increase the amount of training data from left to right. For XGBoost, we see that the optimal number of estimators increases as we increase the amount of data. And for support vector machines, we see that the optimal value for the cost parameter is reducing. In total, we consider 9 different hyperparameter optimization, or HPO, benchmarks with elastic nets, approximate k-nearest neighbor, and random forests, as well as XGBoost and support vector machines. We also consider a pricing optimization problem, where we also see this gradual change in the optimal value. To show the benefit of taking ordering into account, we consider a very intuitive method. We start by evaluating the top configuration from each of the 5 previous tasks, and then move on to standard Bayesian optimization. We compare to a range of baselines. The first 2, random search and Bayesian optimization, don't do any transfer. The next 3, bounding box, zero shot, and CTS, are examples of standard transfer HPO methods. In bounding box, we reduce the search space of our current task based on the performance on the previous tasks. In zero shot, we learn a complementary portfolio of hyperparameter configurations which worked well on previous tasks. And in CTS, we map the evaluations to quantiles and learn to predict these quantiles. We also considered 3 ordered methods. In TransferBO, we used a shared Gaussian process to model all of the evaluations across tasks. Simple ordered is the method which I just described, and simple previous is a version of that, but instead of taking 1 evaluation from 5 different tasks, we take 5 evaluations but just from 1 previous task, the last one. And we conducted all of our experiments in SignTune. The metric we use is the normalized score, which compares the performance of the current method with that of the best performing method, and normalizes it by the performance of random search. And for this metric, we want the value to be as low as possible. We start by comparing the performance after the first evaluation. The green bars are the non-transfer baselines, and they don't do well. Then in red, orange, and yellow, we have the standard transfer HPO methods, with CTS in yellow performing best. Of the ordered methods, TransferBO, so a shared kernel, is shown in purple, simple ordered is shown in dark blue, and also with arrows pointing to the bars, and simple previous is shown in pink. Of these, simple ordered and simple previous work best, and they also are the ones that work best overall. The light blue and the black bars are ablations. We also see that simple ordered and simple previous do very similarly, which is good because it shows that the ordered approach is robust to exactly how we choose to exploit the ordering. We also compare the performance after 10 evaluations and see that which method works best depends on the benchmark. So for News Vendor, which is the pricing optimization benchmark, TransferBO works best. For XGBoost, CTS works best, and for SVM, simple ordered works best. Our takeaways are that you can get improved transfer by taking the ordering into account. And if there isn't an ordering between the tasks, then you should be exploiting that to get as good performance as possible. For small evaluation budgets, we recommend using the simple ordered method. And we want to highlight the potential for combining this ordered approach with more sophisticated standard transfer HPO methods. For instance, we could use those same 5 initial configurations which we use in simple ordered, but use it to start the TransferBO approach instead, so using all of the evaluations in a shared kernel. Or we could use it combined with the reduced search space from bounding box. Thank you for listening.